right, so now we're going to talk about the angle of elevation and the angle of depression. The angle of elevation is formed by your line of sight, so where you're looking, and the horizontal. But the reason why it's called the angle of elevation is because you're looking up at an object. So this would be the angle of elevation. The angle of depression is also formed by your line of sight and the horizontal, but it's the angle of depression because you're looking down at an object. So this is the angle of depression. So in this figure, there's some angles of elevation and depression. It says to label the angle of elevation and the angle of depression, and then what do we notice about the two angles? So let's start with person A. Person A is looking down at person B. And that's the line of sight that I just highlighted. And the line of sight and the horizontal line create, for this one, an angle of depression because person A is looking down. Person B, their line of sight, they're looking up at person A, and their line of sight and the horizontal connected to their line of sight would form then the angle of elevation. Now, since both of these angles are formed by the horizontal line, these horizontal lines are parallel to one another, and the line of sight kind of creates the transversal running through these two parallel lines, which means that the angle of elevation and the angle of depression are congruent by the alternate interior angles theorem. So let's go ahead, let's write that down, let's explain. All right, so let's get started. An air traffic controller at an airport sights a plane at an angle of elevation of 29 degrees. So let's start to draw this. You can use dots to represent the airplane, or you can do your best in drawing one. I'm going to do my best in drawing one. Please don't make fun of my drawing. I am not an artist. But here is my airplane. Okay. The plane's altitude is 3,500 feet. And the air traffic controller, which is this person here, they are looking up at the plane in the air, and that's their line of sight. You do need to know, if I ask you what's the line of sight, you need to know it's where they're looking. So they're looking up at the plane, and their line of sight and this horizontal line that I'm drawing in create my angle of elevation, which was given to us as 29 degrees. It states what is the horizontal distance between the plane and the airport. So we're trying to find this line that I just labeled X, the horizontal. So in relation to that 29-degree angle, we have the opposite side on my right triangle, and we're trying to find the adjacent side. Opposite over adjacent is tangent. So I'm going to take the tangent of this 29-degree angle, and that would be equal to the opposite side, which was 3,500, over the adjacent side, which is X. Solving for X, I'm going to need to get X out of the denominator of this fraction, so I'm going to multiply both sides by X. So I wind up with x times the tangent of 29 is equal to 3,500. And then dividing by the tangent of 29 on both sides, I then get x by itself. It does say to round to the nearest foot. So x comes out to be, in my calculator, I'm going to type in 3,500 divided by tangent of 29. X comes out to be about 6,314 feet. And that is how far horizontally the plane is away from the airport. All right. A forest ranger in a 90-foot observation tower sees a fire. So we're going to draw a tower. And this person's at the very top of the tower. And they see a fire down below. So they're looking down like this. And then I'm going to connect their line of sight to that 90-foot observation tower, like so, to create my right triangle. Now the angle of depression is 3 degrees. What that means is that's formed by the line of sight, which is that purple line, and the horizontal, which is this line here. So this angle is 3 degrees. Knowing that my two horizontal lines are parallel, my line of sight is the transversal, and by the alternate interior angles theorem, this angle down here in my right triangle is also 3 degrees. We want to know the horizontal distance to this fire, so we are trying to find this that I labeled as x. In relation to that 3-degree angle, I have my opposite side on my right triangle, and I'm trying to find the adjacent side, which means that I'm going to use tangent again. So I'm going to take the tangent of this 3-degree angle, and that would be equal to opposite over adjacent. Getting my x out of the denominator, multiplying by x on both sides, I wind up with this. And so now getting x by itself, I'm going to divide by the tangent of 3 on both sides. And it does say to round to the nearest foot. So doing 90 divided by the tangent of 3, I wind up with about 1,717 feet. All right, so the next one, we have a pilot at an altitude of 12,000 feet. So let's draw ourselves another plane. All right, that plane's flying at 12,000 feet. And this plane, the pilot sights 2 airports directly in front of him. So this is airport 1, and this is airport 2. And the pilot's looking down at both of these airports. This one here, and this one here. All All right, I'm going to finish off this right triangle by connecting those two airports, my altitude line. All right. The angle of depression to one airport is 78 degrees, and the angle of depression to the second airport is 19 degrees. So the angle of depression is always formed by the horizontal and the line of sight. So the angle of depression to airport 1, which is this whole angle, is 78 degrees. But that's also this angle down here. And the angle of depression to airport 2, which is just this angle here, is 19 degrees. But that's also this angle down here. We want the distance between the two airports. So if I use my first triangle, I would find this distance here, which I'm going to label as X. If I use my second right triangle, I would find this distance here, which I would label as Y. And then to find the distance between the two airports, it would just make sense for us to do Y minus X. So that's what's going to be done here. So looking at my yellow triangle, using the 78-degree angle, I have the opposite. I'm trying to find the adjacent, that's tangent. So the tangent of that 78-degree angle is equal to 12,000 feet over X. Getting X to the other side, I multiply by X. And then dividing by the tangent of 78. It does say to round to the nearest foot. So when we type this into our calculator, we wind up with 2,551 feet. Now I'm going to do the same exact thing, only with my green right triangle using the 19-degree angle. I have my opposite side. I'm trying to find my adjacent side, so that's still tangent. And sorry, I should have used the variable y throughout. Rounding to the nearest foot, I wind up with the distance of 34,851. So then to find the distance between the two airports, we would just subtract the two. So 34,851 minus a 2,551, we get a 32,300 feet as the distance between the two airports. That brings us to the end of this video, but for your homework, you may need to know that there are 5,280 feet within a mile, and you may need to know the formula distance equals rate times time. All right, have a great day.